References mentioned in the text are listed at the end of the video. In 1989, Timothy Parker and colleagues at the Jet Propulsion Laboratory began analyzing the topography of Mars's northern lowlands for evidence of shorelines that would indicate the existence of ancient oceans. Reference 2. In 2001, Clifford and Parker published a paper, Reference 1, that delineated their findings in this map, showing the locations of several proposed shorelines. The two most prominent shorelines are Arabia and Deuteronilus. The area mapped is from 15 degrees south to 65 degrees north. Clifford and Parker did not attempt to test their hypothesis, or did not publish an attempt, so I was determined to do so. The proposed shorelines consist of discontinuous boundary contacts between landforms, thought to have been created by waves or water-related processes. However, the elevation of the contacts varies enough that they do not support a shoreline interpretation under present conditions. Also, some areas of the purported shorelines could have been obscured or altered by later physical processes, and there is evidence to this effect. To test the idea that the proposed Martian shorelines could have resulted from bodies of water, I needed a way to create an accurate three-dimensional model of the planet. To do this, I used ray trace rendering. Creating the virtual model. I used the NASA Mars Digital Elevation Model to create a topographic surface matching that of Mars. Then I rendered a blue sphere superimposed on and concentric with the topographic model and adjusted its radius to intersect the topographic surface to simulate an ocean. The Mars model is sized in units equal to the equatorial radius of Mars in kilometers. Thus, by adjusting the radius of the blue sphere, the virtual ocean can be made to intersect the topography at any elevation, as shown in these images of the inner and outer basins. Matching the shorelines. The ocean sphere in the model is initially a perfect sphere, so it must be distorted to simulate a tidal bulge. I considered two types of bulge, an equatorial, or oblate bulge, and a polar, or prolate bulge. If Mars, as asserted in the Saturn myth, was one of the planets in the polar alignment configuration, then the ocean shape would have been prolate. If Mars, orbiting the Sun as an independent planet, once had a large ocean that created the proposed shorelines, the ocean would have been distorted by planetary spin to the shape of an oblate spheroid. Because the shoreline map extends from 15 degrees south to 65 degrees north, I extended it to the poles to accommodate fitting it to the virtual Mars model. Then I wrapped the extended map around the Mars model. Using a polar stereographic projection of the shoreline map on the Mars model, manipulation of the following ocean parameters can be used in an attempt to match the shorelines. The type of tidal bulge. Displacement of the ocean pole in latitude and longitude. Adjustment of the volume of water in the ocean. These images show best fit results for two of Clifford and Parker's proposed shorelines, Arabia and Deuteronilus, with polar and equatorial tides. This image shows a prolate tide on the left and an oblate tide on the right, fitted to the Arabia shoreline. This image shows a prolate tide on the left and an oblate tide on the right, fitted to the Deuteronilus shoreline. In both cases there are areas that do not fit, but the prolate tide is slightly better for the Arabia shoreline. And it is, by far, the better fit for the Deuteronilus shoreline. From longitude 210 to 218, latitude 31 north, on the northwestern part of the Tharsis Rise and on Acheron Fosse, there is a short section of the Deuteronilus shoreline. The prolate tide fits that section of the shoreline exactly. This is definitive evidence in support of the existence of a prolate tide on Mars in ancient times.